Hi Chem Peeps. This is video 2 under Hess's law and completely under the umbrella of thermodynamics. In this video we're going to do a sample problem, and so the problem reads aqueous barium sulfate can be formed by reacting barium oxide and sulfur trioxide or hydrogen sulfate or sulfuric acid. Which method of forming barium sulfate has the greater enthalpy change? Use the following data to determine the delta H for the reaction between barium oxide and sulfuric acid. So if you look in this problem, they give us two reactions, and in both reactions they give us the enthalpy. Now, the reaction that they're really interested in is this last one. In other words, we're going to use Hess's law. We're going to add these in such a way that we get the reaction below. And if we can do that, then I can add the heats to form this. So let's look at the problem that we're looking at. What you want to do is you want to look at your final reaction and see where it's found in the reactions above. So if I look here in the final reaction, here's barium oxide. Where's barium oxide found in reaction 1 and 2? Well, it is right above it on the reactant side. It happens to be 1 mole, and there's no barium oxide anywhere else in the two problems, and there's 1 mole in the answer. They're both on the reactant side. So I actually want to leave reaction 1 the way it is so that when I add them, the barium oxide is added down. Okay? So let's look at the next thing in our equation. We have sulfuric acid. We have 1 mole of it. Well, where is it found in the two reactions that we start with? Well, it's on the product side. There is 1 mole in both of these, but it's on the wrong side. So what I actually need to do when I go to add these is I need to turn this one around. Okay? So I always tell my students, after you've analyzed your reactions, rewrite them the way that you need to have them. So the first reaction I need exactly as it is, barium oxide solid plus sulfur trioxide gas produces barium sulfate. Okay? And that's aqueous. And I'm going to leave my delta H the way it is because I didn't change the reaction. Now, the second reaction, we determined that we need to turn it around. So let's go ahead and turn that reaction around. Now my sulfuric acid is going to be a reactant instead of a product. And then my reactant of sulfur trioxide, sulfur trioxide gas plus water in the liquid state. And I said I'd turn this around. So what's going to happen is I'm going to make a negative of whatever my delta H was. Well, it was originally negative, so now it's going to become positive. So instead of negative 78, we have a positive 78. Now, when I add these two reactions, if I get this last reaction here, then I know I can add the enthalpy. So let's simplify anything that can be taken out of the reaction. And I think I forgot something. I did. I forgot my... no, I did it. I'm sorry. I was jumping ahead. Okay, so if we simplify where we can simplify, we'll make the problem a little bit easier. So we have sulfur trioxide gas on the product side here, and it's on the reactant side here, so it simplifies. So I'm going to add down what remains. So I'm going to have barium oxide in the solid state plus the sulfuric acid in the aqueous state produces barium sulfate in the aqueous state plus the water in the liquid state. And this actually matches the reaction that we're trying to solve for right here. So that means I can add my enthalpy. So the enthalpy for the formation of this is actually going to be a negative 135 kilojoules. Okay? So that's an application of Hess's law. I'll do 2 more examples of this in the next 2 videos. Check them out on TikTok and YouTube at Chem's Chem Chats.